Hey and welcome back. So last time I watched the last video and I saw I didn't do a very good introduction of what we're actually trying to do now and how it works. So I will kind of start over with all of this and explain it from scratch. So where we ended up is now we have our implementation of a board. It supports 2 players. We can actually we can throw over, we can do chain reactions. So in theory, we could now build a game around this where I play myself or something like this. But maybe I should implement this first. Unsure. For now, I wanted to start with an AI for it. Let's maybe start with a game loop first, and then we go to MinMax, just so that we have a game. I always forget how to do input in Python. Terminal. I think it's just input or read or something. Raw text input. So let's do our game loop. We make an empty board. It will be very simple. You can just play yourself for now. While true, print. We print the board. We then ask the user to input something. So, okay, our input format, I don't know, will be something like this for now. Maybe later on we can have something 1A, 1B, something more closer to chess. So, we also don't do any input validation. I should actually stick to single quotes. I find them more nicer. And you should catch that potentially we might then invert an invalid move. In this case, it would hopefully throw an exception. Print E, and then we just do it again. And this one, so this one would be our game loop. While true needs to be changed to the winning condition. And we last time actually wrote a function for this, winning player, while not winning player would be our condition. So as long as we don't have a winning player, we print the board, we ask to give a move. And then we try to move, and then we print the board again. Let's just see if we can run this. Wow, why is my screen broken like this? Oof, okay, again. Okay, one thing I noticed is we should print a new line. Something like this. So 0, 0, 0, 0 doesn't work. Cannot move on top of another player. 1, 1. I also thought maybe the first couple of moves maybe we should, if the field is empty, maybe we should skip the first couple of moves. So if a field is empty, you can place 3 stones immediately, otherwise it takes forever until you can fill up a... sorry, playing, it's fine. Oh, what did I hit there? Ah, okay. Ah yeah, if we... this should be here. Okay, so now we have a simple game loop. We can basically play ourselves. And the fun part about it will be writing our first AI. The first algorithm that we're going to implement is just a simple MinMax algorithm with no additional tuning. From there, I plan to write a performance method, which is also usually used in chess. What performance does is it tries searching the game tree up to a given depth, and it records on how many nodes were visited, how long did it take, what's the best move, and we can then use this to benchmark our algorithm, and then we will improve it with alpha beta and maybe some hash tables along the way. So first I'm gonna make a simple min-max algorithm, then we're gonna do performance. And the way how min-max works is for a given position, for a given board, it gets all possible moves, it tries all of them, and plays out against itself. So let's say we're in a position of an empty 3x3 board, something like this. So now min-max would start top left corner for now without anything. It starts placing something here. And depending on how deep we search, then it would make a move for the enemy and say, okay, what are the next possible moves? Maybe this. So this one was red, this one is now blue. And then now it's red's turn again, and red would try every possible move. So it would start with this one, and up to a given depth, we just try all possible moves and try to figure out which one is the best in the end. So for a given board, we play all possible moves. Then after playing one of those moves, we play all possible moves for the enemy. And then after playing a move for the enemy, we play all possible moves for ourselves. And then try to find the best move. And the way this works is we try to get the best move for a board. Actually, I don't necessarily need a class for this. But yeah, maybe I should get this move for a board, and this will be our interface to the outside, and internally we have a method called maximize, and this also takes a board and a depth, and then here we just call this maximize function. It looks weird, isn't this written with a Z? It's probably American and British, but Z looks more correct for me. And then let's say, I don't know, by default now our AI has a depth of 3. This will eventually be a parameter, or let's immediately make it a parameter. Yeah, okay. So, okay. So now we call this minimize function, and what this minimize function does is it first checks if either depth is equals to 0 or someone won. Let's say we made a move and then we won, so we don't need to continue. And maximize will be a recursive function. This will just call itself. Next we need to get on all possible moves. And then we need to make the move. We need to maximize for other player. And the algorithm is called MinMax because one player tries to minimize the score, the other one tries to maximize the score. So if I call MinMax on a board position where it's player 1's turn, we try to maximize the score of player 1, while player 2 tries to minimize the score of player 1. So it tries to find the move that gives player 1 the worst outcome. So we would call maximize for the other player, and then we undo the move. Get score, get make move, we call this for move A, undo move A, and then this is basically the pseudocode on how it should work. So now let's just code it down. So if the depth, did I do here? No. If the depth equals to 0, or board winning, or we have a winning player, then we return. Now we need to return the score. Let's just score for now. This will be 0. We will implement this in a second. So at this point in time, we need to somehow evaluate what would be the possible score. And then we need to do all possible moves. For move, did we already get best move? No. Let's just name this function possible moves. We need to implement that, and then board. Board. Nobody's telling me undo. Next move. Now let's just call it undo. It's nicer. And we know it's the last move that we are undoing. We're never gonna undo something in between. And here magic, and then score equals magic, and then if score, and here best move equals, and here we would return best. Okay, something like this, right? If we are at depth 0, we don't want to search any further. If a player already won, we also don't need to search any further. So let's make this in separate if conditions, because we're going to have different valuations here. We return a score of a really good score for the previous player. We assume, I think it's safe to assume that the last player that moved is also the player that would have won. And here the score magic will actually call, so now we need to, I already said it, we need to call self maximize for the other player. So for the other player, we want to do the exact same thing, except we want to minimize the score for the player one stack up. So here we would actually pass board and depth -1. And the trick here, in order to avoid having two functions, is to negate it, because this function will return the maximum score for the player that is to move after we made a move, so our opponent. And the bigger this score is, the worse it is for us. So when we look for the biggest score in this step, if we find the biggest negative number, which means it's the worst outcome for our opponent. This took a while to wrap my head around when I initially did it, but it shouldn't be too bad. So, and we start with a really high negative bad score. So for whatever reason, let's say this returns -1 or something. -1 would already be better than nothing, so this is the best move. And then next iteration, it returns 2. So 2 is better than -1, then we record this as the best move. Here you can see if somebody won, then we return minus, how many is this? -1 million. This is a really good event for the player that just moved. And in case that we reach depth 0, we somehow need to estimate how is this position for the player. One thing I'm going to do is I'm just going to count the number of boxes for each player and return that. So we want the boxes for the current player, and we want to subtract, and we think which way around we need to do it. So in the last step, we make a move, then we go down, depth is now 0 in the next step. And same as we have to return -1000 now, we need to return what is the result for the player that just made a move, which in this case would be the other player. So we take the boxes of the other player and we subtract the boxes of the current player, and this would be the score. Let's test what happens if we execute this with, let's copy this into our game loop. I don't know. Game for later. I don't know. Don't need it right now. Next we are gonna do board. We're just gonna search one. Get best move. This should be fairly random because if you just do one move on an empty board, there should be nothing that you can find. Get best move, and here just pass the board. And we takes no parameters. MinMax takes no parameters. One second. Why is this happening? Tab error object takes no parameters. Why is this an object? Am I blind now? Ah, okay. Not sure what that was. Yeah. And down here we forgot to remove the OR. Funny. Board, print. And of course we didn't return this one. No right since last change. Awesome. And now I need to be careful not to execute the wrong. We always want to execute game pi. board has no attribute possible move. Oh yeah, we didn't implement this. We still need to return a list of possible moves. Did I not implement this? Okay. Yeah. We need to make another loop over the board. If and we need to get the player. If the player at this position is current player or not. So in order to get all possible moves, we get all empty fields and we get all fields that have the color of the current player. Let's do this. I told myself I should be a bit slower in those videos now. I think I'm rushing through, but I'm kind of excited to get to a point where we can start tuning. And the rest is now just implementing the basics, so maybe I'm not going to talk as much as I want. Okay, if there's no player at this or that, then moves append like this moves. I actually thought we implemented this last time. Okay. We also don't have undo. Yeah, of course. Yeah. Okay. I should write a couple of tests for all of this too, which I will do later. For now, let's just get this to work, and maybe in the next episode I can spend a little bit of time cleaning this already. So boxes 4, possible moves, and then undo. So undo can be a bit trickier. The way I'm going to implement it for now is because say we place a box and we have a chain reaction which potentially changes the whole field over multiple steps. It's complicated, and what I'm going to do is I'm going to have a history, and every time we make a move we just copy the whole board and save it. I think this is how it's called, to call copy nested Python data structures. This is not the most efficient way, but we're gonna tune everything later. So copy, deep copy. So now move function. Now before we do anything, we make a copy of the board. And we're gonna append it through triple. So we append the current player, the copy the board, and copy self-player. I think this is all the state that we need. If we make a move, we append this, and then if we undo a move, let's take our undo function and move it closer to the move function. So if we undo a move, the thing is we do, I think you can do pop on the list, and here we get this is I think this is it, right? Everything that changes is covered. Okay, now we have an undo. I should test this. The board. I need a. So, one thing we want to note is even after we called get best move on it, nothing changed. Yeah, okay. For tuple. Yeah, because the function below returned a. Here it returns a score and here it returns a move. Oops. Score. No. This is just a. There's no move associated with this. And here. Let's go best move. And here we return move. This was one of the issues. Yeah, 1 second. Let me think. So now an issue is that I'm actually returning mixed types from this function. Up here I return a number and a number, and here I return a move. Give me 1 second to figure out how we do this. We call maximize, and in case a move comes back, so we are actually move. We will return a move and a score, and then just negate the score here. And then move, best score, and here we do not have a move. And here we don't care about the move. I actually was about to override the move variable. This is a bit the pain of non-type languages. Okay, now it returns a move and a score. Okay, and then to see that actually something happens, we can print the score in between, the board in between after every move. So here we can probably, oh, yeah, that's already so many moves that we have to check. It's a 5x5 board, which is now you got me. I can't calculate, I can't code and think at the same time. 25. Oh god. It's late here. It is really late. So okay. It's already 25 moves, and then if you go down 5 to the power of, let's see, if we go down depth 2, depth 3, there's already 15,000 moves, so yeah. Printing it is already quite tedious. Let's see if we can do from custom board. What do we need to give it? Maybe we can start with smaller boards so we can understand a little bit what's happening. And let's give it a obvious best board. Something like this. Should have copied the rest as well. From custom board. So if we give it a board like this, where there's an obvious best move, any of the 4s would win the game. We should actually see, let's maybe not have this set as a possible move to see that it would also choose something else. So here it recommends we should place at 0, 2. Which seems weird. 0, 2 would be here, no? Like this would be the last board state. So score, no, let's debug this a little bit. Score 2 minus 2, score is 2 minus 3 minus 2. Is it doing what it is doing? Let's even simplify this problem a bit more. And 0 is correct. Here we can see everything it does. So this is the current board here in depth 1. Let's actually print it as well, depth 1. Okay. Here we start out. Actually, this belongs together, so okay. Let's print it like this to make it nicer. Okay. We start out, then in depth 1 we find a score of 5 after we did this move. How do we get 5? Basically, we go down 1 further in the search tree, making it depth 0, so we just calculate our metric, which is 9 minus 4, which is 5, and then let me just see, he made a move for the red player, and yeah. How does that work? Yeah, it is late and I'm not entirely sure. So one thing we should do is current board add move, this one, for here we can do. So this is the current player and this one is. So now we print some more information. We want to print the length of the history, which tells us which move we are at, and then what's the current player. This will help us a little bit to understand what's going on. So we are at move 0 for player 1, and then we are at move 2 for player 1, which means now we already made 2 moves. One was in the top left corner, and then red moved into the only other place red could move, down here. This gives us a score of 5. Okay, at depth 1. So after red moved, we go down 1 further in the tree. We discover that depth is now 0. So we go up 1 further. We go back up and return the score of 5. And then in here, where it's now the turn of the green player, it was the turn of the green player, it's a -5 for player 2. So we start out with player 1. Here we have 5 for player 1, -5 for player 2. And then 1, 0 for player 1. Okay, 1 more second. Let's make a little bit more output. Here. Depth. Did I really write depth 1 here? This is good. Depth, and we can So because we only print after the fact, right? Okay, now we have a little bit more. I don't know here. So this is the beginning board. Then at remaining depth of 2, we make the move 0, 0. Then at depth 1, we make the move 1, 1. And then at depth 1, we found 1, 1 gave us a score of 5. And the board is like this. And 5 is the 9 minus 4. So player 1, who started out, would get a maximum score of 5. And then if we go back up further in the search tree, back to where we made the move 0, 0, this is a minus 5 for player 2, which is correct. Then we have another move here, we immediately win and we return it, and we have another move here and we immediately win and we return it. Okay, we have this part, and then now we wanted to go back to the bigger board. I also see this is running a little bit long, so we're gonna end it here soon. Maybe I'm gonna clean this slightly up off camera, but so here. Ooh. Where do we start out? Here. So this is start. We move at 0, 0, we immediately win. Sorry. Let me change this back. Okay. And then maybe this. So now some stuff happened. Let me go up, 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 up. So here we found a variation where actually red 1. Yeah, MinMax is always zipping around. Okay, here. This is where we start out. Does this work? Okay. Here we start out. This is the board. We make move 0, 0. Then player 1 starts with 2, 1 as the first possible move. And in this situation, we find a score of minus 2. This is how it looks like. So the first player moved here, the second player moved here. Now we stay and just check what if the second player moved here instead. It's also minus 2. What if the second player moved here instead? It's also minus 2. What if the second player moved here? It's also minus 2. And here we flip over our tower, and then we find it's minus 1. So potentially this got better for player 1. And then we play here and we find it's minus 2. And then what we found is the best possible move that we can get here is 1. And I need to double check this because I'm pretty sure that since this is the worst possible move for the red player would never make this move and choose any of the other moves. So up here, where we get back up, the score should actually be 1 for player 2. For player 2. We start out as player 1, right? Yeah. And then 1 moves, 2 moves. And then this is the best score that I can get as player 2. Correct? It should be the other way around. As player 2, I can get 2. Yeah, interesting. So let me see. Current player. It needs to be this way around, I guess. 0, 0, minus 2. Anyway, this episode is running very long, so I'm gonna think about it and come back in the next episode.